Good evening, good evening, good evening, ladies and gentlemen. WeatherBrains episode 892, the pre-show. This is for the 20th of February, 2023. I'm James Spann. It's the magical part of the program where we do three things. We share boring personal stories, humorous anecdotes, and from time to time, we say outrageous things. All right, people are waiting to join. Let me get the embed code locked in here so we can get on television. And we will get this thing rocking and rolling here. Interesting weather week for the United States. Some people buried in snow. Some people were in their tank tops and flip-flops. All right, 1, 2, 3 are in the waiting room. Wow. All right. So, show number 892, February 20th, 2023. And I've had a great series of days here. Busy series of days, but a good series of days. Very good. All right. Got James Adelot in Tulsa at Fox Weather Headquarters in Tulsa, Oklahoma. There he is, ladies and gentlemen. Action news, total news, eyewitness news. I don't even know what they call our newscast. I need to know our branding. I have no idea what we're called here. I should know that. I've been here 26 years. Will, can you hear us okay?
Yes, I can hear you.
Okay. Christine, can you hear us okay?
I can. Thank you.
Okay, well, good. We're communicating telephonically then. That's good. We'll start the show here in about 6 minutes. For those that are watching, just move the slider over. Most people listen. But we'll hit once we hit the TV at the top of the hour, we'll go, we'll get this thing started here. Yeah, James turned his camera on, immediately turned it off. I don't know what that means. But yeah, it's an interesting week. We've got some of the northern states. They're going to be hammered. I mean, hammered with a winter storm, with some spots getting 2 feet of snow or more and some icing problems on the southern edge of the snow. And then down here in the deep south, we've got the warmest weather so far this year. We will be in our tank tops and flip-flops this week with highs exceeding 80 by Wednesday and Thursday. So pick your type of weather. It's all out there this week. I think Minneapolis, St. Paul is going to see 2 feet of snow. And if nobody else comes on the show here, I better do my prep here. Bill Murray should be here in a moment. And I think everybody, well, Troy, I think that Troy said he would not be able to make it possibly tonight. He might come in late out in Austin. But Rick and Jen and Kim and Dr. Jacobs and Bill, I think, will be here. And if they're not, who needs these? We don't need no stinking co-anchors. That's what they say in the television business. All right. Yeah, I'm pulling up my notes frantically here. So in case I have to do the interview segment, I will be somewhat prepared. See, a lot of people don't know how this works. This is when some of us work, like James Adelot and James Spann. We're working. This is a work time for us, and we have to multitask, and that's why Bill Murray takes over the interview segment while we handle business at hand. But there they are. They're all coming on the show now. So we're good, Bill. We were worried that you might be 50-cent beer night at Hooters and you weren't going to make it, but you're here. You made it.
I wouldn't miss this show for anything. I've been looking forward to it for a while.
Okay.
Especially with Dr. Harper staying up in the middle of the night. You already cover her time zone over there, James. She's 1 a.m. in the morning.
No, I'm 2 a.m. in the morning. Actually.
2 a.m. in the morning. Google lied to me. I guess that's true. Yeah.
We're
an extra hour.
Yeah, we're an extra
1 hour ahead of Greenwich.
1 hour ahead of Greenwich. Yeah.
Well, we appreciate you staying up late. We'll try to make it worth your while.
Actually, I just got up. I went to bed very early. Went to bed at 8. so that I could get some sleep timing, because I teach 3 hours in the morning. So I've got to
Oh,
be
boy.
alert and ready.
You'll be ready for lunch by the time you get to your first class.
Yeah,
You don't need
probably.
sleep. You don't need
Yeah.
sleep. I've
Yes, we
gone
do,
without it.
James.
I have gone without it since 1973.
You're an
And,
outlier.
I feel
Well,
better
so
now
have
than I
but I
felt when
don't
I was
teach real
30.
well that way.
I'm at the top of my game when I've had no sleep, and that's when I say really outrageous things. Is when I've gone a whole week with no sleep, and I'll come into one of these weather conferences, and I'm the speaker guy. Like,
Was he out of control at Ohio State, Jim?
I was here ready to say, is that what happened
Yeah.
at Ohio State?
Unhinged, totally unhinged.
No, it was great. I loved it.
No.
You had me
Um,
laughing and you made me cry. It was good.
Yeah, and Monday. People say they don't like Mondays. What's the matter with these people? Mondays are great. That's when I've had more than 3 hours of sleep a night. I'm refreshed. I'm energized. I love Mondays. I mean, I don't know why some people don't like them. Every day at my age is a gift. I mean, it's so.
It's all about that mental attitude about it, James.
I celebrate.
It's proven now that people who have a positive attitude about aging actually live longer.
Yeah, I mean, come on. Let's see how we do. Like I played tennis last night, and those guys said you run faster than most 18-year-olds out here, in which I didn't. It's a short distance now in the tennis court. Now, if I had to run 10 miles, that ain't happening. I mean,
so you haven't made the move to pickleball yet, James?
No, that's some hipster thing. No.
Oh, it's fun. Oh, I love pickleball. I got a
y'all
paddle and everything.
You guys are hipsters, and I'm not a hipster. I'm a square. Hip to be square. So I'll stick with tennis. That's what everybody says. Hey, man, you ought to be playing pickleball. Tennis is old and tired, and nobody likes that anymore. Come on.
James, it's been 2.5 years since I played tennis. I took a break because of my back, and I'm going to go out next week and go hit. So
yes,
I'm going to try to get back out there and I'm not going to be I'm so competitive, but I'm going to try to back off a little bit and just go have fun and just go hit a little bit. So
for WeatherBrains 1000, part of the package is going to be a tennis match between the two of us and anybody else that wants to play on the show here.
Yep.
And it's not going to be pickleball. It's going to be real tennis.
Real tennis.
So
that works.
that's the deal. All right. We got 30 seconds and we can get started here. We have to wait for the TV folk.
Introductions ready here.
Will,
can you hear us okay? Have you already checked in with Will, James?
Yes,
we've already.
I am. I'm just listening in. Since this is my first time on WeatherBrains, I'm just going to keep my mouth pretty quiet and just make comments as needed.
Will has decided he's going to hang up and run after this. I mean, he's
I'll fill in for
testing
Troy.
his options right now.
I'll fill in for Troy since he's a good friend of mine.
Yeah. But
Yeah,
anybody
I was hoping
with
Troy would
this
be on here, too.
Aurora display behind you like that's cool. I mean, I feel like we're going live to the Arctic Circle for the display of the Northern Lights this evening. And welcome to our television viewers. It is top of the hour. We're on the television side, and so we're going to get this thing started here. So let's hit record button number 1, track 1 and track 2. And here we go in 5, 4, 3, 2, 1.
Join the American Meteorological Society by becoming a member of the band. The AMS Weather Band is a global community of weather enthusiasts dedicated to learning and sharing their love of science. Visit amsweatherband.org to learn more and join the band today.
WeatherBrains, episode number 892. This is the weekly show all about weather, the world's longest running weather podcast. It's about 1 million of these things now, which is great. But we've been on the air since 2006. How about that? Over 17 years now. Thanks for joining us. We got a good show tonight. And let's try to see who's out. Rick Smith is here. Rick from Oklahoma. Rick, how are you? What's the weather doing out there? Are you going to be in the cold air regime or the warm air regime here? We've got a nation divided this week.
We're enjoying the warm side of that right now. Some are calling it fake spring or fake spring #1 or something like that. But we had 70 today. Parts of the state got up to 80 and even more of that. And got another windy day planned Wednesday. I can't remember what day it was last week. It was just, large sections of Lubbock, Texas are now over Oklahoma. The dust and the dirt that we had blowing in. Hopefully it's not like that again this week. But yeah, we've had all kinds of cool stuff. But fortunately, we're warm and supposed to stay that way at least another couple of days, hopefully.
All right, James A., how about you? What's happening in Tulsa town?
Oh, things are pretty quiet. We weren't quite as warm as Rick today, but we all looked down at Durant, who hit 80 degrees. And I think we're going to stay on the warm side of this thing too. Thursday and Friday are going to be cooler, but after last week, it was 39 Thursday and that wind on Valentine's Day. Pretty much anything that could be thrown at us this week, we can deal with after last week.
Yeah, you can handle that. In fact, last week was interesting. We had an enhanced risk bust here, which, the haters were out big time. Oh man, they were. I think my favorite was the guy that wanted to throw me in jail for 30 days. And I actually looked this guy up. He's a former police officer. He was mad. One guy said he wanted to stab me in the heart.
No way.
Oh yeah,
You didn't issue the enhanced risk.
They never tell me that. They know I don't have a heart.
But yeah, we should do another mean tweets. That was a good one. We had a lot of nasty ones. But as I always say, you cannot hurt my feelings. You cannot in any way, shape, or form hurt my feelings because I have no feelings left to hurt. Dr. Jacobs, do you have any feelings left to hurt?
No, I've got a really thick skin and a giant archive of hate mail to go with it.
Yeah. I think all of us on the show should compare hate mail sometime, just to make us feel better. A group hate mail session here. But Neil, you were not on the show last week, and we sure were looking for you to get into the balloons, aliens. I mean, this had your name written all over it last week. So.
We're gonna have to do like an official alien UFO show because I'm really disappointed I missed that.
No, we've got to do that at some point because
I love the New Yorker cartoon I saw today. So these two eagles flying, and one turns to the other and says, "No matter what you do, don't look like a balloon."
So Neil, where are you calling from this week? You in Florida, North Carolina, Washington, D.C., Walla Walla?
I'm in North Carolina now. I'm flying up to D.C. in the morning, there the rest of the week. But I am going to be headed to Miami for a couple of weeks here, I think probably end of the month.
Okay, going fishing?
Fish
yeah, probably. Definitely
Yeah.
can't not do that when I'm down there.
Yeah, no, you got to do that. So we'll come back to Dr. Jacobs here in a second. Let's see, Jen Naramore up in Ohio. So are you in this winter storm watch warning thing, or is it north of you?
It is north of me. We are on the warmer side. We're going to get rain and storms. It's kind of like what you dealt with it when you were here a couple of weeks ago, where it's going to be really windy and we get really warm and then we get really cold, but no snow. So I'm fine with that.
Yeah, it looks like some of our friends up north are going to be buried with this thing. It's going to be a whopper of a snowstorm, but more about that later. Bill Murray, let's bring in our guests because some have gotten up really early or stayed up really late to join us on this show.
Yeah, James, first introducing our guest panelist. Will Hathaway is a meteorologist from Texas with an MS in atmospheric science from the University of Massachusetts, Lowell. Will, welcome to the show tonight.
Thank you for having me. It's great to be here.
Well, I thought it would be good to put you in a show with some modeling, and we're going to talk about numerical weather prediction tonight. But you're a GitHub code developer, and you've made a self-install script for the WRF, and we want to hear about that a little bit later, in addition to your work with wet bulb globe temperature. So hang on for a little bit. We want to, I guess I was worried about getting Dr. Harper to bed, but tonight, since she was staying up so late, but now she's already up, so she can just do the whole show. Tonight's guest WeatherBrain is a meteorologist, oceanographer, and science educator turned historian of science. That's a fascinating transition. She authored this fabulous book, Weather by the Numbers, The Genesis of Modern Meteorology. She is currently at the University of Copenhagen? Is that
University
right?
of Copenhagen. Yes, that's correct.
And so I guess that is just a screen background in your probably
That
from
is-
your university there.
That is the screen background of the new Niels Bohr building. It houses the Niels Bohr Institute, which is the physics arm of the university. That's also atmospheric sciences. On one side of the street, and it's connected by a sky bridge that you can see there to the other side of the street, which is the chemistry building. And I'm in science education, and we are on the ground floor of one of those two buildings.
Literally at the ground floor.
Literally on the ground floor.
Intersection. So what's
Yeah.
the weather like in Copenhagen right now?
Yeah,
upcoming
currently 44 Fahrenheit, blowing 20 mile per hour from the west northwest. So it's kind of warm here for this time of year. You know, it could be a little cooler. That would be fine with me.
Yeah, we're going to Germany in late May and early June. And so I've been studying the weather and climate over there. And I think during that time, the highs are about 20 Celsius and the lows are about 10, but it's considerably cooler than that right now in Deutschland. So they'll be watching that with a lot of interest. Talk to us about your current job. I want to hear about what you do right now and then kind of walk back through your journey.
So I work for the Department of Science Education. In Danish, that is the Institute for Naturfagnes Didaktik. And I'm part of the History and Philosophy of Science group there. So what I do is I teach a class called Geologiens Videnskabsteori, which basically translates to the history, philosophy, and sociology of geology. And so all science students here in Denmark have to take a class in the history and philosophy of their discipline. It's a required course so that they know how and why they think the way they do and how they approach problems and what's methodologically acceptable and what are the ethical problems they could face and all of those kinds of things. And we meet from 9 to 12 this morning. So you know, like I'm already up and ready to go.
Well, that is good. We'll have you ready to go for your classes. Now I contacted you through Florida State. Take us back through your career path and your education.
Yeah, so meteorology was not on my radar, so to speak. So I have my undergraduate
James
degree.
I'm sorry he was away for that pun there.
Yeah,
Dr. Harper, he's our king of puns.
Yeah. So I got my degree in mathematics from the University of California, Riverside campus and joined the Navy. And while I was at Officer Candidate School in Newport, Rhode Island, they said, where do you want to go? And I said, any place out of the country, you know, like I did not join the Navy to go back to California. And so as it turned out in 1973, that was the first year that Officer Candidate School went co-ed. And it was also the first year that women were allowed to be assigned overseas for their first tour. So they said, well, where overseas do you want to go? I said, I don't care. You know, as long as it's out of the country, I don't care. And so they said, how about Guam? I said, fine, I don't care. They said, well, you know, there's a weather center in Guam and they need a computer officer and you've got that background. So how would that be? And I said, super, send me to Guam. And they came back 2 days later and they said, Guam says they already have a woman out there and they really can't deal with another one. So they said, how about Rota, Spain? The weather office at Rota, Spain doesn't have a woman. Would you be willing to go there? And I said, oh, you know, like force me to go to Rota, Spain. So off I went to what was known as Fleet Weather Central, Rota, Spain. And they actually did not know what to do with me. They put me in a conference room by myself for 2 weeks with a stack of manuals to read because they said, well, you know, like we don't have women here. And I said, well, you know, like I'm here now, folks. So I was there. I worked in the computer shop. I wrote code. I punched cards. I got yelled at when the models coming from Monterey bullseye, as if I had some control over that. And I learned about the weather and thought, well, this is really cool stuff. But my next assignment was with the Navy Recruiting Command in beautiful downtown Pensacola, Florida. And then from there, I ended up back in the weather business. And then I just stayed there. So I was at Pearl Harbor for 3.5 years, and then was sent to graduate school. Navy sent me to graduate school. And then from there, back to Rota, Spain to be the operations officer. Nope, sorry. In between, I was aboard ship for a year doing deep ocean survey in the South Atlantic. Came back, was an instructor at the Navy school, and then went back to Rota, Spain and finished up in Iceland for 2 years. And once I retired, I started teaching at Western Oregon University. I was teaching meteorology and earth sciences while I was getting my teaching credential. And they asked me to get a PhD like right now. And I said, well, okay, well, how about history of science? Because many of my students were science phobic, and there's nothing like teaching a bunch of science phobic students science. So I just decided to introduce it historically. And they calmed down enough so that they could understand what was going on. And so I did. I went and got my PhD in history of science, focusing on the atmospheric sciences. That produced my first book that you showed there on numerical weather prediction. Did a postdoc, wrote some books for kids, went to New Mexico Institute for Mining and Technology, got a couple of big fellowships to do my second book on weather control, then ended up at Florida State for 12 years. And now I'm at the University of Copenhagen. So that's why I'm here. I'm here to teach.
There's so much to unpack there. James Adelot, you're first.
It's so uncomfortable with our 2023 perspective to hear you discuss things like that were so chauvinistic in the 70s and even into the 80s.
Well, and we're going to carry that theme through tonight. Rick Smith's guest at 8:00 is who, Rick?
Liz Lightman from the Storm Prediction Center.
Have you heard about this, Dr. Harper? What happened with her last week?
have. Yes, I was reading about it, and I went, you go, girl. But it's about time.
Yeah.
Awesome.
And I found myself cheering her on last week, but then realizing, Lord, why are we even having this conversation? But there's some reasons, obviously, behind that.
There are some reasons for that. Yes, there are.
Rick, you were going to chime in there too. I didn't want to cut you off.
Well, I was just going to say I'm fascinated by how many times you've moved. I've moved like 4 times and thought that I was really doing something, but I would love to see. I would love to see you narrating all those moves with like the old movie with the line going across the map. And man, you've done a lot. It's very, very impressive.
Let's just say every move was over an ocean.
That's
every
cool.
move was over an ocean.
Incredible.
In 21 years, it was back and forth over an ocean. Put the stuff in a crate, over across the ocean. Wait 3 months for it to show up. Live on borrowed Navy furniture in the meantime. So when my colleagues at Florida State heard that I was moving over here, they said, you would just pack up and move to Denmark? And I said, are you kidding me? No sweat. This time I'm not even moving kids and a dog, and like I'm just moving myself. Piece of cake.
I'm fascinated by those European countries. Dr. Harper, talk about the culture and what civilization is like there.
It doesn't include lots of guns. I'll tell you that right now. So it is delightful. I've been actually in and out of Denmark since 2010. I was a visiting professor at Aarhus University, which is over in Jutland, back in 2011 for 4 months while I was working on a project about science and technology in Greenland in the Cold War, which was a really interesting book project. And so I've been collaborating with Danes for a number of years, and then got a call from here saying, hey, would you like to come to Copenhagen? And I said, I would be delighted. So I just bought an apartment. And so what you're not seeing on the screen behind me is my current apartment, completely torn up because I'm really in the middle of moving catty corner across the parking lot to my new flat, which I just bought, and I'm painting before I move all my stuff in. So I tried to get all the paint out of my hair before this transmission so that people didn't think I was totally strange. But
I think we've met somebody
yeah.
that sleeps less than James.
Really? we have a winner. We have a new winner.
Yeah. But it's great. It's very walkable. I walk everywhere. I'm 5 minutes from public transportation, and most of the time I walk, and it's great.
Well, how hard is it to get a visa?
Great.
Because I may be looking for a visa here soon, Dr. Harper.
Well, I'm on a work permit, right? So, yes, I've passed my Danish qualifying exams, and I'm set.
And we welcome Dr. Kim Clocko-McLean to the show tonight. Kim, welcome. We've got Dr. Christine Harper tonight as our guest weather brain. Will Hathaway's joined us too from Texas, but she's in Denmark in a fascinating position as a teaching the history of science and to some geologists, it sounds like. So I think this will be right up your alley, Kim. And we're glad you're with us tonight. So you spent some time as an oceanographer, Dr. Harper, right?
Well, in the Navy, meteorologists and oceanographers are kind of one and the same thing. Originally, when I came in 73, they were two different groups. Okay, they were two different coded groups. And then they were joined together a few years afterwards. And so we became known as Navy meteorologists and oceanographers. And then after that, the whole unit was referred to as the Naval Oceanography Command. This was a political decision more than anything else, but we were doing a lot of meteorology. So most of the oceanography we did was in relation to anti-submarine warfare. I mean, it's the Navy. And so we did that. We did wave and surf forecasting for amphibious units. We kept people safe, right, and able to do their job operationally.
I know Will Hathaway has a question. Will, why don't you go ahead and ask that?
Dr. Harper, being a history buff myself, what exactly do you talk about in your classes about the history of geography?
I'm teaching history of geology, actually.
Oh, geology.
Yeah.
Sorry,
yeah,
my mistake.
That's okay. That's okay. I've done geography too. I'm doing geology right now. So basically, I start with my students kind of a little bit pre-19th century, before geology became professionalized, just to talk about the differences between how early on you had people who were mineralogists, who were really focused on mining and finding ores and minerals, right? Because that was the practical kind of thing to do. And then people who were theorizing, and kind of they were theorizing without a whole lot of evidence, let's put it that way. And the theorists kind of got a bad rap. And so you see this changeover in the late 18th century into the early 19th century, where evidence becomes really important. Like you have to have something solid to point to. You can't just have a big idea and then spout that. And so we talk about things like, in fact, we have a 5-week-long exercise that ends in a role play at the end of how European and British scientists figured out how glaciers worked and where these big erratics come from. I mean, it's really startling to see really big erratics in a place like Denmark. There aren't any mountains here. All right. Somebody was joking that if you fell off the highest mountain in Denmark, you'd be slowly rolling down the hill to the bottom. So like nobody's dying climbing a mountain here. And there were all these kind of reasons for, well, where were these big rocks coming from? And so there was a big fight between folks that argued, well, glaciers could have done that, except like, where's the ice now? Or they would have been rafted in on big hunks of ice that then melted and then left them there. And so the students have to take all of these different parts and read the primary literature that these folks wrote at the time, and then present that as if they are Charles Lyell or Charles Darwin or William Buckland or any of these people that were, and some of them were upset about that. They said, well, but this doesn't make sense. I said, it is 1840 and it most certainly does make sense. You have to remember that how your discipline looks changes over time because people have additional evidence, they have more discussions, and then what's legal and what's not legal and what's acceptable to do and what's not acceptable to do, that changes. And you need to understand that it's not something that's static and it's over and it's done. And then we just move forward in time and talk about things like people who think we can predict earthquakes just like we can predict the weather. Actually, no. And then what happens when people think you can, and there's a bad earthquake like there was in Italy, and then people get charged with manslaughter because people die. And what are you going to do as a geologist if somebody asks you to fudge information about an environmental impact study, and you say, oh yeah, it's really safe to build on this hill, and then everything slides down and people die, right? So what are you going to do about that? How do you think about these kinds of problems? So all of it's tied up together, right? How they think about things, what's happened in the past, how it changes over time, how that impacts them in their work life, and the ethical considerations they have to make, and how they communicate that science to stakeholders and the regular public so they understand what they're talking about.
I think it's great that. Oh, sorry. I think it's great that you get your students to look at the primary source material, because I was a student getting my master's. You read about these famous scientists and then just a 5-second or 5-sentence summary of their work, but to actually physically read their source papers, or even if you're luckier to hold them, you find out so much about the insight to these scientists.
Yeah, that's right. And what unfortunately, what often is included in those little 5-minute blurbs in textbooks is often wrong, right? Because it makes it look like it was just one straight shot. We had this idea and then ta-da, in 10 years, it was all a done deal. Not, heck, we fought over this for 40, 50 years first. And it's important for students to realize that, plate tectonics didn't just come out of no place. There were huge
Kim,
arguments over that.
You've got a question, Kim.
Yeah, sorry, I didn't mean to circumvent what you were going to say there either, Christine. It's really nice to meet you, and sorry that I missed your introduction, but I hope this isn't ground that you already covered, but I'm really interested to know, in your work doing this, history of science and instructing on it, you're talking a lot about the context that scientists lived in probably being important too. So how much of what you teach is the geology, and how much of it is the socio-political and economic climate, no pun intended, that the science was born within?
Right. Yeah, I talk about all of it. I mean, it's all interwoven. It has to be, or it doesn't make sense anytime soon. I mean, my class is now about half women, right? Which is really, compared to the olden days, right? When I came into meteorology, where there were hardly any women running around at an AMS meeting. And my first AMS meeting wasn't until the early 2000s, because I was trotting all over the world in the Navy and I never had a chance to, I wasn't going to be flying in from overseas for an AMS meeting. And I just looked around and I thought, seriously, I've been in this business for 30 years and there's still only this handful of women running around here. This is completely ridiculous. And now I've got a geology class of 24 this cohort, and about half are women. And they're saying, where are the women in this story? And I'm saying, well, actually, the women were often very wealthy. The wives of these geologists in the 19th century were often very wealthy women, which allowed their husbands to be geologists because they weren't being paid for this. They were gentlemen geologists. And many of them were excellent artists and good geologists themselves, right? Traipsing around in the boonies with their husbands, collecting rocks and making sketches, but they didn't get any credit for that. And so my women students are saying, we want to hear about some gals here. And I said, yeah, well, we'll finally get to them. But, that's kind of towards the end of the line. 19th century, not so much. And these are the reasons why. But it all has to be there because the science and how that gets developed makes no sense without the context behind it.
If you don't mind, I'd love to ask a follow-up, Bill. So, okay, for that field, then what are some of the more important evolutionary pushes and pulls? So there are probably some things that were in the economic or political environment that were going on that pulled geology in different ways. And there would have also been at the same time things going on within the science itself that would push it. And those things that, as with our own science, that's happening today. There are things our scientists love and want to do, and there are things that politicians would rather have us work on. And so it's always this dance between, well, who's funding you and to what end? And what is, so that scientific frontier is always being negotiated. What are some of the big things that you cover in your course? What have been some of the big forces that have propelled that field forward?
Well, in the history of science, the bottom line is you always have to follow the money. You always have to follow the money, right? Who's interested and who's willing to fund it, as you pointed out. So our original folks who were doing field science, which had been natural history until the 19th century, all as one lump together. Those folks, the early folks, were basically just following their nose because they were all wealthy guys. They were wealthy guys who had the time not to work, because they had money, right? They just had streams of money. They didn't have to work, or they were for the Brits, amazingly. So the Brits were often parish pastors, right? They were Church of England pastors, or they were appointed as such so that they had income so that they could go out and look for rocks, right? I mean, it's really an amazing kind of thing. And so for many of those people, it was totally curiosity driven. There were other folks who were sort of being paid by the government, they were being paid by the government, but there wasn't kind of a formal structure for them yet. And that was all on the economic side. Where can we find more coal? Where can we find the minerals that we want? For the Brits who were expanding the empire, what's out there and what can we exploit and bring back and use for ourselves? And so you have two kind of different groups that are moving along those lines. In the US, we don't even really get started very much until the late part of the 19th century. The Europeans very much are on top of this, primarily focused economically, with a handful of academics who, like I said, can kind of follow their nose. In the US, it's very much driven by US Geological Survey. Early part of the 20th century, there were any geologists in the US who hadn't worked for the USGS at some point. Unlike on the weather side, where all meteorologists worked for the US Weather Bureau. I mean, literally every meteorologist worked for the US Weather Bureau. Not all geologists worked for USGS, but they'd all worked for USGS at some point. I mean, if you didn't have a prayer to be a geologist. So it was very much driven by governmental concerns. And so for the most part, you see geology being driven by governmental concerns, whether that's safety or whether that's minerals or whatever it is. To a large extent, that's still true, except now in the 20th century, you also have big businesses who are involved, right? So, I mean, you've always had mining, but you have oil and energy groups. You have, hydrologists kind of fit into this earth sciencey group that's connected. So you have those people. You got water people who are concerned about where the water's going, where the groundwater is, where the groundwater isn't, or do we have aquifers that are being drained as the ground falling? And so you see a lot more environmental questions as we think of climate change kind of things. You see a lot more environmental questions driving research than you did before. And of course, during the whole of 20th century, you saw a lot of wars driving things. So military geology was really important because you need to know if you can take a tank over a piece of land someplace. You don't want to be caught. And so military geology, the work I did in deep ocean survey was all about bathymetry, it was about gravity measurements, and it was about magnetics, right? So that too was all folded in as something that's related to mapping and figuring out the seafloor and how that was moving. So that's essentially where we are at this point.
Yeah, those are a lot of really interesting actors and forces that, promulgated the science forward in different places. And, the geography, you covered some of this, the geography in which the scientists are situated matters too. What government you're working for or what group you're working for. And you raised a lot of really interesting points. I want to take you back to something you brought up near the beginning of your answer to that question, where you were talking about the Church of England and a lot of geologists being driven by curiosity, but also being from the church. It's my understanding that geology has had a really interesting history with religion. It can sometimes be, especially around that point in history, I think it was that there was some negotiation going on about, do we believe these, theories of an older planet? And how do we grapple with our role in the arc of history, and as defined by what the science is saying versus what our doctrine is saying? Are these things actually in conflict? And it's interesting to me that it would have been clergy. I mean, I understand why in some respects they would have been the most learned people. They would have had access to, reading and the methods of reading, and all the literature was often held in their libraries. But how were they also as stewards of the growth of that kind of knowledge? Was there a tension there?
Actually, not as much as people think. This whole idea that religion and science were in opposition is just not the case. I know people think it was, but really it wasn't. And for these geologists who are working on this, there was no conflict for them at all. I mean, the reason the clergy are involved, whether it was Church of England folks in the UK, or whether it was Catholics in France and Lutherans, and depending on where you are on the European landscape, what you were at the time. The clergy are doing this work because they felt that as part of their faith, they were obligated to uncover the creation of God's creation, right? And they didn't look at it as, oh, the Earth's only 6,000 years old. They knew that wasn't the case because they saw evidence of how old it was. And they didn't know how old it was, but they knew it was really, really old. And there were a handful of people who thought it wasn't, but they weren't taken seriously by anybody in the geology community. So there really was no tension here. This whole kind of conflicting idea between science and religion, this is really more of a 20th century thing than an early on thing. And that I can never figure out exactly why people think this. I mean, they look at Galileo, but even that was political. I mean, Galileo, you can't insult the Pope, who happens to be providing you money for your research, and then think that that's going to end well. I mean, it would just be like one of you folks, saying nasty things about the head of the National Science Foundation and then wondering why your next grant wasn't funded. I mean, seriously? I mean, you just can't pull stuff like that. So So these guys, no, there was no conflict for them. Many of them were actually church leaders. I mean, some of the Brits were very, very prominent. And that's why they had time to do this. I mean, because they had guaranteed incomes, because they were a canon of something or other, right? And they'd been stuck someplace, made them a church leader, and they handled that job, but they had time to go around and try to figure out how erratics moved across the UK.
That's really interesting. Thank you for honestly setting some of the records straight on that field and how religion had cultivated it and related to it in those early years. And I'm not going to monopolize the conversation. We're having a fun time in chat talking about this, but I do want to zoom forward in time then to the latter period. You talked about the emergence of things like environmental concerns, and I'm thinking about the intersection between geology and our knowledge of glaciation and the pressing issue of climate change, and the intersection between atmospheric science and geology. One of the most natural intersection points is obviously us understanding current and past climates as a way of understanding future potential climates. So this is going to be something that's so in your wheelhouse because of all of the work that you did too, working in oceans, and atmosphere. Where is the field of geology today in contributing to our understanding of how all of this works in the broader Earth system?
Well, that's an interesting question. I would say from discussions with my students who are very keen on this environmental part. I mean, we're living in Denmark. This is really low country here, right? So last week when the news came out about the work on the Thwaite Glacier in Antarctica, and I showed him the clip that was in the news that showed the little sensor that they sent down through the borehole, and they went around and explained about the melting of the crevasses being faster and how much that could contribute to sea level rise. And one of my students says, yeah, as if we're living on a big mountain here, right? So they are very much concerned. They are very much concerned as geologists about things like sea level rise and helping people to understand why this is a problem. And many of them want to work in environmental impact kind of research. So there used to be quite a number of students here, just as an example, who worked in petroleum geology. That's almost entirely vaporized. Like nobody's interested in that at this point, right? They're really interested in all these environmental issues and about melting glaciers and what's going to happen if the precipitation doesn't fall as snow but falls as rain, and you have increased erosion, and you've got faster water moving down hills, and what that means for the landscape that's down below. So I think we'll be seeing, based on my students, I think we'll be seeing a lot more work on this kind of nexus with atmospheric sciences and looking at the overall global system. We talked about that last week, actually, with my class, about the intersection of system science and how you had to consider all of the systems that were involved and not just your own patch, which we tended to do years ago, kind of look just at our own patch and not to see how all of our Earth science systems were connected.
Dr. Harper, this is really cool that your students have the opportunity to not only learn about the science, but they're learning about the settings that science was developed in, and the normative values and the social settings and things like that I think it's kind of disingenuous to discuss scientific developments in nearly any field without having that perspective at hand. So I guess it's more of a comment than a question. I sound like people in the audience at a conference. I've got more of a comment than a question. No.
Well, it is important. And that's, that's what historians of science do. And philosophers of science as well. So most of my colleagues here are philosophers of science. And my students, when they come in, this is a required course for them, right? So they're thinking, oh man, like we've got to write and we've got to read all of this stuff. And, I just want to be out in the field collecting rocks. But once they get into it, they're saying, this is like really important. Like I need to know this before I'm out being a practicing geologist. And I say, yes, you do. That's why we're here. This is really important to think about, because they say you are going to be influenced by political decisions, and it's going to depend on where you're living. And this is also an opportunity for you to influence policy, but you need to approach it in a way that policymakers can understand. And if you talk to them like you would talk to another geologist, that's not going to work so well. If you talk to the general population as if they're geologists throwing a bunch of jargon around, that's not going to work so well either. So you need to be listening to people. You need to listen to their concerns. Same goes for policymakers. And then you want to mediate that conversation so that you can get your point across, being aware of all of these other factors, that can't just be changed on a dime, that are not maybe optimum for what you want to do in your science. I mean, we've all faced that in meteorology, right? Where there are things that we could say, it would be really cool if we could do this because then we could affect this. And there might not be any money for that. It might not be politically acceptable at this point to do that. There may be a half a dozen other reasons why we can't do that. And it can be really frustrating, but yelling at people is not a help, And so, going into big spins about baroclinicity and vortex centers, may or may not help out. And so we really need to explain what's going on, and we need to think about what people's problems are.
When you address and deal with people, either yourself or other people dealing with policymakers, what has been some of the most surprising resistance you've gotten to where we're kind of advancing the process of this science?
Okay. So I haven't been an operational meteorologist since 94. One of the things I don't miss is calls in the middle of the night. Let's put it that way. But what used to frustrate me when I was on active duty was working for people on a base or supporting afloat units who seemed to think that we could control the weather for them. As in, but I need this kind of weather for this kind of operation. And I'd say, well, I understand that, but that's not what we got. This is what we have. You can move your ship to some place where you can get that kind of weather, or you can stay where you are and you can modify your operation, but you can't stay where you are and get the weather that you want. And it always amazed me that people who had spent a lot of time at sea just had a hard time with that concept. And were just insistent that they had to have it a certain way. And I had meteorology friends who were out, and they'd ring up and they'd say, okay, like, I know you understand this, but how can I get my commanding officer to realize that I can't produce the weather he wants? I said, be patient and just explain it as many times as you have to. Like, what do you do with that? We can only forecast what's going to happen with the data that we have. We can't create the weather that people want. I think that was the biggest frustration for me when I was on active duty, or people being surprised when what the forecast was happened and they weren't ready. And they said, well, but we didn't think that would really happen. I said, well, like I told you, we were going to have a quick warm up and all the snow was going to melt and it had to go somewhere. And now it's in your electrical substation. And I'm sorry about that, but you were warned. And they said, well, what are we going to do now? I said, I'll pump the water out of the electrical substation, I guess. I mean, like I don't work for Public Works. I'm just the weather officer here.
Well,
So
certainly
those kinds of things are annoying.
They are, and we're constantly called on as forecasters in a role where they sometimes are lobbying us for a certain decision, because they know there is a probabilistic, component to what we're telling them. I need to paint this building. Is it going to rain over the next 5 days? And they're already lobbying you to say that, well, maybe it won't. But I wanted to circle back to something you said, because Will Hathaway has a little experience in dealing with policymakers in Texas. Will, have you run into that, into what Dr. Harper's talking about in dealing with those legislators?
Yes, so I have been working with legislators for the wet bulb globe temperature, which you've had another web call on WeatherBrains call about. And I found that when you're talking with legislators, you really have to explain it simply and concise. You can throw some technical jargon in there to show that you understand the science, so they know at least you're an expert in your field. But there is a lot of pushback when one legislator wants to see a bill go through and another one has obligations to their constituents to not see it go through. So even though the science is strong and for the wet bulb globe temperature example that I'm working on, it's a good thing for the general population, the dynamics of the politics really changes what happens. And it goes back to what Dr. Harper said. It's all about who's funding you and what their motivations are. And until you have a grasp of understanding who and what you're working with, you can't really tailor your talks to them with it. Because you could, if I came up to a legislator and said, oh, hey, this is going to help sports, and their biggest lobby is Gatorade to sell liquid to the fluid to the students, well, they may not want to have more canceled practices or stuff like that. So it's really all about knowing who you're talking to and the motivations.
Yep.
Well, Dr. Harper, I've got a lot of ground I wanted to cover tonight. We need you for about 3 hours, I think. But we want Dr. Neil Jacobs is our resident expert on numerical weather prediction. I'm sure he'll have a lot of commentary and questions or debate for you. But take us back to Lewis Fry Richardson for a minute, and his theory, and then into the Meteorology Project and John von Neumann and all of that, how it started. Dr. Neil, you're on alert here to throw in anything you can add along the way.
I'm fascinated by the history of this. And I say that from the context of I was working on an ICAMS paper for BAMS with Kelvin Drogemeyer, and we wrote a history about NWP in the US. And one of the reviewers, and I had sort of this was from the reference frame of the Weather Bureau and the Army, and one of the reviewers was having none of it. They were like, that's not how it happened. Let me tell you what really happened. And then I realized that it's still kind of contentious about where it got started and the different bureaus and everything else. And there's a really interesting book called Thor's Legions about the history of it, at least from the Air Force and Army perspective. And it's pretty fascinating that it's still like one of the whole point of ICAMS was trying to bring the different agencies together. And they're still arguing over it. Right, exactly.
Well, Dr. Harper, start us off. Take us back to the early days around 1946 and kind of how you saw it unfold in your research.
Okay, so you mentioned Louis Fry Richardson. So basically, what Richardson was trying to do was he was trying to take the work of the Bjerknesses and make it come to life, right? So the Bjerknesses at the Bergen School, they've got equations, right, that they're going to use to so presumably then you could calculate the weather, right? Because you've got these equations. Unfortunately, they were nonlinear, which meant that they were going to solve them anytime soon, right? You couldn't have a direct solution, and you were going to have to use numerical methods. And Louis Fry Richardson, who was a Quaker and who was driving ambulances during World War I, basically in a barn on piles of hay, set out to hindcast an event by drawing squares on the map and then interpolating the temperature and pressure to a point in the center, and then using numerical techniques to move the whole thing forward 24 hours. It was a horrible bust. I mean, it was just like way off the charts bad. But he wrote about it. And I'm forever telling my students it would be lovely if there were, there was a journal called the Journal of Stuff That Didn't Work, right? So that we don't keep doing the stuff that doesn't work instead of publishing the stuff that does. But anyway, he publishes what didn't work, which was amazing. Because then by 1946, when we had actual computers to do this, not very powerful computers, of course, ones that had less than my cell phones got in it, they had the opportunity to try this out. And so the initial look was to go back to Richardson's book and see what he did and say, okay, well, let's start here. And so this basically came about because John von Neumann was getting ready to put together yet another new computer. He'd worked on the Manhattan Project down in Los Alamos. Now he's going to build a new computer, and he wants a really nasty problem to solve on it. And like, what's worse than the weather? Really? I mean, there's just no contest. So folks had heard about this. Carl Gustav Rosby got involved. I think he could, charm feathers off of a bird, this guy. And he went and talked to von Neumann and said, look, I think this is really a good idea. This is what we could do. I can get a team of meteorologists together if we can get funding for this computer. So they went to Office of Naval Research, which forked over money for this and formed what was then known as the Meteorology Project. And so the Meteorology Project was in tandem with von Neumann's efforts to build this new computer, which was dubbed the Johnny-Ack. And so we see people who entered, most of the people who were involved entered meteorology because of the war. So before the war in the US, we had maybe 600, 700 meteorologists tops. Almost all of them worked for the Weather Bureau. And then we trained up 7,000 meteorologists for the war effort. People like Joel Charney, who never in the world would have been meteorologists, right? So we pull in all of these mathematicians and physicist type people, and they get pulled into this meteorology project. And so we have this nucleus of people in Princeton, New Jersey, because that's where von Neumann was. And they set up shop there, and he's working on his computer, and they're doing stuff by hand with calculators, trying to do the calculations in between until he can get his machine online. And they use ENIAC, which had been built for the Army to do what we call fire control solutions. Okay, so that's aiming artillery guns. And they used that in the meantime until his computer was ready to come online. And it was joint Weather Bureau, Navy, and Air Force, with the Navy and the Air Force providing the money, and U.S. Weather Bureau providing advice. Yeah, and that's basically how it got started. And the initial products were not so good, but by golly, their reports all said it looks great. You know, this is really promising. If they'd been honest, they never would have gotten any more funding. But the military really wanted them to succeed, because part of the sales pitch on this was that if you could forecast the weather with the computer, you could control it. And so
that's what you mentioned earlier, you know, that your people in the field wanted you to control the weather for them. But was this a selling factor of it?
Oh, and most certainly it was.
Did they really absolutely believe that they could do it?
Yeah. They they wanted to believe it. I mean, it doesn't matter. It doesn't matter whether they believed it or they wanted to believe it or they thought it was a good idea.
Well,
they were willing to put the money forward for it.
What year was this? Around when?
1946.
This is the late 40s.
Okay, so that actually totally syncs with some of the popular lore of the time. Dust Bowl history. If you've studied it, you know that we tried to take control of the Dust Bowl by like anthropomorphic means on the ground. We thought the rain follows the plow and other things. Like we really there was this idea at the time, very much in the public consciousness, and it made it's so interesting. And even all the way up to the science, that there was some ability to control those outcomes. So interesting.
Well, but the reason they thought so is because the people who were doing this were lab people, and you can control all kinds of stuff in the lab. You just can't control it in the atmosphere. But their idea was this, and this is using 21st century speak, that if you could put in variables and get a meteorological chart that you wanted, okay? Well, so let's say you need sunny and light wind and maybe a few puffy clouds, right? Okay, so you decide what your surface and upper level need to look like to produce that. You produce that on your screen. Well, they didn't have screens, but you know, on your printout, and then you say, that's the weather I want. Now we're going to go outside and we're going to influence those variables outside, and then we're going to get the weather that we want. And the Navy was like all over that. It was like, hot damn, you know, like that's the coolest thing ever. You know, because we got ships at sea, they don't like being beat up. I mean, you guys talk about getting hate mail. You ought to get messages from ships that have gotten beat up, right? You know, like we'll get a message and say, you are aware that it's really windy and we've got water coming up over the top of the, ship's bow here. Yeah, we know that. We know. But there's like nothing there's nothing we can do about it right now. Go, like take your ship and go someplace else. I mean, it's not going to be good there. But that was the selling point, amazingly enough.
So by March of 1950, they're ready to do their first attempt at forecasting the weather. How did it turn out, Dr. Harper?
Well, so they're not really forecasting, they're really hindcasting, right? Because they've got to use a situation that they've already seen before. Because otherwise, how do you verify, right? I mean, because it took over 33 days, they were only able to run 2 12-hour forecasts and 4 24-hour forecasts. And it took longer to run the forecast than the forecast period. So like it wouldn't have worked out really well. So what they found was that, and this is a quote, they looked meteorological. That was the bottom line. So 33 days later, it looked meteorological, and they said, okay, here's some more money, right? So O&R pumps in more money, Air Force Research pumps in more money. Weather Bureau says, we haven't got any money, but we got people. And they just kept at it until, then they tried in 52, once von Neumann's new machine was up and running, okay, Joniac, is they hindcasted the 1950 big storm that it had caused a huge amount of damage and killed quite a few people. And the response after they'd done it was, it's snowing in New York City. That was the response when the final charts came out. They said, we got it. It's snowing in New York City. Okay, well, like it's 2 years later, but yes, it was snowing in New York City. And so then they were just able to continue to upgrade. and then formed like a testing unit starting in 1955. And then by 1960, each of those groups had their own numerical plan. The Air Force had its own group, the Navy had its own group, and the Weather Bureau had its own group. So actually, that's pretty darn fast. I mean, they thought they were going to have this up and ready to go in 2 years. That was totally unrealistic. But 15 years later, not so bad.
Well, from one groundbreaker to another, do you want to jump in and introduce Liz Lightman, who's joined us? We'll do her full introduction in just a minute. But Liz, so glad to have you here. You're jumping right in the middle of a amazing, awesome conversation going on here. So just want to introduce Christine Harper to Liz and the gang here. So welcome.
And you're muted, Liz. Unmute for us. We have to do that at least once a show.
There we
or
go.
not a show.
Well, thank you for having me. I'm really glad to be here.
And Kim, you mentioned in chat to Liz, once you point that, what you were pointing out to her.
Oh, sure. Well, this will be part of Liz's story later on, but Dr. Harper earlier was recounting some of the really interesting history of the field of geology and was talking about how she has a corpus of students now that it's 50% female now, and they're listening to all this history and they're like, where are all the women? And Dr. Harper had to say, well, you know, there are reasons, but they don't really feature into a lot of this in some of these contexts for evolving the science until later. And so I think, Liz, that's a perfect way to segue into the story that we'll have about you, and to show that even still in neighboring fields like meteorology, we have some of those glass ceilings to break. So I will just put that out there. That's a foreshadowing for those, if there might be 3 listeners who don't follow you on Twitter, but aren't aware of what's going on, but we'll get there. We'll get there, and it's so good to have you.
Thank you.
So, Dr. Harper, take us on through the rest of this story. Dr. Neal, jump in anytime. Some of this was leaking out to the public there. Was that on purpose, or how much of it was Navy classified and under wraps?
Yeah, so the Navy did leak. Yeah, like I caught him red-handed. So in 1946, when they had their first meeting to discuss whether they were going to support this or not, the Weather Bureau, particularly Francis Reichelderfer, who was the chief of the Weather Bureau and was a former Navy commander, meteorologist, he was trying to keep the whole thing under wraps. So he considered it confidential, but it wasn't really like classified confidential. It was like, okay, like we're just not talking about it right now. And then it shows up in the New York Times 2 days later with the Navy saying, oh yeah, you know, we'll be able to snuff out hurricanes and, you know, like no problem. This will really be great stuff, which made everybody really kind of nervous about that. But the money was flowing in at that point. And so the science, what was then known as Science Service, right now publishes as Science News, or now just as SN. But at the time, Science News had a science newsletter, and it also put together articles that were then published in the media. Right. And so that was the source of science articles. And of course, in those days, there were science journalists. New York Times had 2 or 3 science journalists full time working for the newspaper at that time. So there was a lot in the press about how these big brains, you know, it was always like, you know, WeatherBrain will forecast the weather. And then it shows them doing ENIAC, and the women. And there were women there because all the programmers were women with patch cords, patching in the program, because it wasn't done even on cards. It was done with patch cords. And so they would patch the program in literally into this computer that took up a monstrous amount of space. And so there they were featured. And I always loved that because they were shut out of almost everything else, but they were the ones that were doing the programming. And yeah, everybody thought that, you know, computers were just going to be spitting out weather forecasts, you know, anytime. and you could just like rip them off and go with it. So it was not in any way a secret. It was really kind of overly hyped what they were going to be able to do. But yeah, it was in the press.
I wonder where the future is going to lead with NWP, because I've run in this a little bit, and will probably appreciate this as well. All the development work we're doing with the community weather models is now on GitHub. It's all free and open, and I've run into situations where there are pieces of code, ocean model code and other things, where putting it out on the internet for anyone with a IP address to use is frowned upon. Do you think there's like, they're going to have to get on board with this open source community modeling program? I mean, how do they keep an edge from the national security perspective?
That's a really good question. I was asked several months ago to kind of update the NWP situation and what it might look like in the future for a like a compilation of articles, kind of for a specialized encyclopedia. And so I was getting up to speed by reading one heck of a lot of articles about this. And I just thought, holy moly, like, what do you do when everybody thinks they're a meteorologist? I mean, and I had people telling me this years ago when I was getting my PhD in history of science. One of my history of science professors said to me, oh, he said, I know as much about the weather as any meteorologist. And I said, and why do you think so? He said, because he said, I lived in Norman, Oklahoma for 20 years and I watched the Weather Channel. And I said, great. Okay. I said, actually, no, you don't. But we'll just kind of leave it at that. But I'll talk to people and they'll say, well, I've looked at the charts, I went here, I went there, I've listened to all of these people, and, like, who needs a meteorologist for this? All I have to do is just kind of do it myself. And I'm just thinking, scary, because it was scary enough. Like when I was in Iceland and the weather was dangerous there in the winter. I mean, people could die. And to tell people, I was doing TV weather in those days we had our own armed forces and radio television station on the base. And so I was weather on the base, and I would get on. And at one point we had a system coming in, and we were either going to get nothing or we were going to get about 3 feet of snow. I mean, it was just, and it was only like a 50-mile difference. And so I got on television and I said, this is the situation. Tomorrow we could have nothing, or we could have 3 feet of snow on the ground. And I said, I'm not good enough to tell you where we are in that 50-mile range. I don't have the data for that, but you have to be prepared for 3 feet on the ground. And so if you don't have food, if you don't have diapers for your kids, it was a base, it's dark, we had lots of babies, right? If you don't have those things, you need to be ready. You might not need it, but you need to be prepared. And that's a lot different than somebody just kind of taking random information and then coming up with them and thinking they can take it to the bank, instead of, this is really nuanced, and you need to take in more things into account and not think you've just got an answer. And that's what concerns me about things that are out there, that people will be convinced that they know more than they know, and they'll tell other people.
If only you had Twitter
really
back then.
Kind of bad shape.
Could have told you everything you know on Twitter.
Thank goodness there was not Twitter.
Well,
Thank
Dr.
goodness
Harper,
there was not Twitter.
We're always fascinated by the move from research to operations. Talk about the significance of May 6, 1955.
So So you mean when the joint numerical group got
When they
started?
issued
Yeah.
their first
So
forecast. Talk about that.
yeah. So the
That
Joint
day.
Numerical Weather Prediction Center started in May 1955. This was a joint unit, so it was Navy, Air Force, and Weather Bureau people who were involved here, and they put out their first operational forecast, and that goes out over the fax broadcast. Okay, so for people who are young, who don't remember when we just had we had fax and paper that was burnt with lines. Okay, I mean that's how you got your weather maps, and so that goes out on the facsimile broadcast. At the same time, they were still getting hand-drawn charts, right? So they had their first numerical weather prediction chart come out. They have hand-drawn charts, and most forecasters took that numerical weather prediction chart and went and tossed it out because they didn't trust it. They trusted what their colleagues had always done. And so it took quite a while. Fortunately, the field forecasters would look at what the computer was putting out, and then they would send, not exactly hate mail, but they would send little notes back to the modelers and say, you know what, you're missing this. The models are missing every time. They're missing these kinds of features. And so they'd go in and they say, okay, thanks for that information. And they'd go in and they tweak the models, and then they'd send them out again. And so it was this constant guess and check kind of thing, right? With people sending in comments and then working on the models like directly. And that was hugely important for making this research to operational shift, because without that constant feedback, I think it would have been a heck of a lot slower, and people would have been a lot more upset, and they wouldn't have used the products. It would have been harder for them to use, because by the time they took the hand-drawn products off the air, and the first ones to go were the upper levels, so that the 500 millibar worked better than the surface did, and so they used those 500 millibar computer charts. And when the hand-drawn ones were gone, it was like, okay, we're good with this. And then finally the surface charts got better. And then we're like, okay, like we're good with this. We'll do a reanalysis when we get more data. We were still using acetates and grease pencils, in the late 80s and early 90s, forecasting in Spain, because, this stuff came out. But everybody, of course, has to get in there and think with what's coming out. Nobody was just taking it as it came out. But that mix was super important. I don't know how much kind of immediate feedback it goes now into models, but at the time it was pretty darn immediate.
Yeah, I think I have to open it up to the peanut gallery here, because everyone's talking in chat, cheering you on there with what you said, Dr. Harper. Liz, what's your comment to what she said?
Well, I said the process that she's talking about, we still do that. And, we're not. Is that a warning, Rick?
let's just say Sharpies are not real popular around
yeah,
here
Sharpies,
on this show.
Yeah. Sharpies and colored pencils.
Yeah.
So as Kim says, please talk about them more. So that's pretty funny. That's how we came to know Dr. Jacobs, was over that incident right there. We covered a ton of ground here, and not nearly as much as I would love to cover. As Rick said in the chat, I feel like Chief Brody in the movie Jaws. He turns to Quint and says, "We're going to need a bigger show." And we've been known for some pretty long shows, but we're so fascinated. I wanted to touch just briefly on desalination for a second, because I think you have some experience in that, Dr. Harper. Is that right? Talk about where the state of that is today in our world, and is it an important thing or just an anecdotal thing for the future in terms of water shortages?
I can tell you that in the 1960s, it was considered the next big thing. Along with weather control, which was also a thing. And the point at that point in the US, it was, okay, how can we share this with our friends and not share it with not friends, politically. And the big problem is that it's super expensive. And so to do it reasonably, you needed to co-build nuclear plants with the desal plants, which is a whole other level of complexity. And of course, as we all know, a problem, because you have to store that waste fuel someplace. And we're still arguing about where we're going to do that. And so at the time when nuclear power seemed like, it's going to be the next big thing and everything's going to be nuclear powered and, we won't have to meter electricity and all of that kind of thing. It made more sense, but it never made sense to the point where people thought, hey, we're going to have these desal plants and then we're going to pump all of this fresh water from the coastline inland to, like water almonds or grow rice in paddies. I mean, that never, or cotton in Texas. That didn't really ever make a whole lot of sense. The people who took this and really ran with it were the Israelis. Because they had to do it. There wasn't really a choice. And so I would say that the best use of the technology in a practical kind of way that's made sense has been done in Israel. Bill, you noted recently that there was a plant that was turned down on the West Coast. I mean, there were trial plants that were all over the U.S., one in the Gulf Coast and one in California fairly early on. But, the bottom line is they're expensive. I mean, the membranes and things that they use have gotten a lot better over time, but it's still terribly expensive. And the question was never discussed, what do you do with all the saline material that you take out of the water? That's got to go someplace. And you can't just pump it back out into the ocean, because now it doesn't matter how long the pipe is. And they were talking about really long pipes way out in the ocean. It won't be a problem. We'll just like nuclear waste, we'll put it in a barrel. We'll just throw it out in the ocean. Okay. So we're going to take all of the saline stuff. We're going to pump it way out there, but now you've changed the salinity and you've harmed wildlife. Right. And so you've got all of these, they're just way too many parts. And to me, I'm thinking, wouldn't it just make more sense to be careful about how we use water to begin with? Just for starters, and use it in a really wise way, like not mining aquifers and not growing things that shouldn't be grown in places where there's no water. And then not having to worry about the desal stuff, except for like on Navy ships where you have to use it. So do I think that there will be more push? Sure, because we're going to have more problems. Just like, we've got all these geoengineering solutions coming up, are we going to, put mirrors up and block the sun and, all the latest kind of things that people talk about. And I think this continues to be one of these things, huge cost, lots of downsides, need to be looking at something else, my personal opinion.
Well, thank you for that insight. That's really interesting. And I learned something very important there, and that was very helpful. We've invited a lot of folks on this show tonight. Bruce Jones is joining us tonight from South Carolina. He's at their emergency management convention there. We'll guess what kind of hotel he's in a little bit, but I want to turn it over to Rick. Please stick around, Dr. Harper, since you're up for the day already.
I'm already up.
Pose any questions, any comments to Liz in this next segment, but take it away, Rick.
Well, this has been fascinating, and yeah, we do need a bigger show tonight because we got a lot to talk about, and I'm excited to have our next guest on. Liz Lightman is a mesoscale / outlook forecaster. We'll talk about what that is in a minute at the Weather Service Storm Prediction Center. She's been there since 2002. She started a Weather Service career. I got to work with her right at the beginning of her Weather Service career as a student volunteer at our office, and then she went to Billings, Montana after that, and then Louisville, Kentucky. And then she came back to the SPC in 2010. She's a proud University of Oklahoma graduate from 2006. And last week, she gained the distinction of becoming the first woman to ever issue a convective watch at the Storm Prediction Center. And as James likes to play at the beginning of the show, sometimes that's kind of a big deal. So Liz, we want to welcome you to WeatherBrains. Thanks for being here.
Thanks so much, Eric. I'm really excited to be here with you all.
Well, you've had a crazy week, not just with the weather, with everything after the weather. We're going to get into that in a second, but I do want to kind of get a little bit of background. I'm going to jump through some of this and get to the good stuff here. But I know you started at OU and you volunteered at our office for a couple of years. Then you went to a couple of other WFOs. Was it always a goal to end up at SPC? Was that your goal?
Yeah, from about the time I was in like middle school or high school, I knew that, obviously I had the weather bug since I was a little girl. But especially around high school, I became more aware of the Weather Service and the Storm Prediction Center. And yeah, so it really kind of started then. It's definitely a lifelong pursuit.
And you actually came and visited, right? You came and visited Norman when you were still in high school and visited SPC and the WFO.
Yep, I did. My senior year of high school, I took a trip to visit the OU campus to make sure that's where I wanted to go to school. And on that visit, I came to the Weather Service office and SPC and Nestle.
And I'm not trying to brag on our office. I do that a lot, but I mean, we have a lot of students that listen to the podcast, and it seems like, I know for me, I started in the Weather Service as a student volunteer, and you did too. I mean, talk about the value of that experience, just for the students who are listening and how important that can be.
It's invaluable. So, I was lucky enough. I spent about 10 hours a week, I think, at the office for 2.5 years while I was an undergraduate at OU. And, building those relationships and getting to know people was very important. But on top of that, I basically was trained on how to do much of the entry level position, which at that time was a meteorologist intern. I learned how to launch weather balloons, how to send out products and things like that. So when it came time for me to apply for a job, on the application and all the questions that you have to answer, I mean, I could answer that, I already knew how to do all of these things. And so I had those skills. And so it really was an invaluable experience.
Yeah, that's awesome. I mean, any experience you can get is great, and having that opportunity just a few hours a week makes a huge difference. So like quite a few of the SPC forecasters that are there now and that have been there, you actually started out at a WFO before you got to SPC. We're going to get into some of your specific duties that you do in your job in a minute, but talk about some of the biggest differences working at the SPC versus what it's like working at a WFO.
The experience is vastly different. We use different software to look at all of our data to create our products compared to a WFO. The scales that we're looking at for the things that we forecast are different than at the WFO. We're looking at a regional or national level, whereas at a WFO, you're focused on a much smaller area. And so there's a difference in scales there. And it's just a whole different experience. But obviously at Storm Prediction Center, we're also solely focused on severe thunderstorms. We're not looking at all types of weather. We don't have as much interaction directly with the public. The local offices do a lot of local outreach and things like that. We're a bit more removed from that. And our core partners are mainly other meteorologists or state, national level emergency management, broadcast meteorologists. And so kind of our focus is also a little bit different in that respect.
But we have gotten to team up a couple of times for some outreach, and you helped with something in more a couple of years ago, right? With helped out there. So I think that was really cool. So, well, I think everybody knows the Storm Prediction Center. I mean, it's the center of severe weather forecasting across the whole country. And it's got to be an awesome place to work. I get to stick my head in the door every once in a while. And it's just, that's one of the many things I think is so cool about when I come to work. It's like, I get to work right next to the Storm Prediction Center. Talk a little bit about how the office is staffed. I mean, in a forecast office, we've got maybe 2 people, maybe 3 working. And if there's bad weather, we have to bring in a bunch of people. Talk about the 4 main, I guess there's 4 main positions in the SPC on a regular shift, and kind of a little briefly about what each of those do, and then kind of get in more detail about what you do when you're as a mesoscale / outlook forecaster.
Yes, so on the severe side, because we also do fire weather outlooks on the national scale, but for the severe side, there's mainly 4 forecasters who are there during the day, during the evening. And those 4 different positions, the lead forecaster is kind of our crew chief. They run the shift, they QC all of our products, they kind of, set the tone, lead the conversation, things like that. And they are also solely responsible for issuing the severe thunderstorm and tornado watches. Assisting the lead is the mesoscale forecaster, and we communicate a lot about the environment where we think that storm initiation is going to occur, the timing, storm mode, things like that. And we communicate really closely because the mesoscale forecaster will issue our mesoscale discussion product. And that is basically a heads up to our other meteorologists and the WFOs, the broadcasters, and areas where we think that a watch is going to be needed shortly. And then the meso forecaster will also kind of update the situation, the severe situation as the event is unfolding, highlighting corridors of enhanced severe potential and things like that. Then assisting the mesoscale forecaster is our mesoscale assistant. And the mesoscale assistant does just that. They kind of help carry the load for the mesoscale discussions because covering the whole country with just one person writing mesoscale discussions can be a bit overwhelming, especially on those really busy days. So we kind of tag team together to do that. We'll sectorize based on risk level or the various threats and hazards for the event. And then the 4th person will be our outlook forecaster, and they are working on updating the convective outlook for the current day, issuing the outlook for the next day, things like that. And pretty much the day shift mirrors the evening shift as far as shift duties and who all is there. We do have an overnight outlook shift, and that shift can get interesting whenever we start getting into busier weather because the overnight outlooker will do the day 2, the day 3, and the day 4 through 8. And so that shift gets really busy as we head into the warm season. And on the mid shift, we only have 2 forecasters because generally, the weather is generally not as busy overnight. And so it's usually just the lead and the mesoscale forecaster.
Really, really interesting. And I think one of the things I've always thought was so cool about the SPC, and some weather service offices do it too, but you always see the names at the bottom of the product. You see the author of the product, and we're going to get into your name being at the bottom of a product in just a second. But I always thought that was cool. The ownership or the whatever you want to call it of the information. Obviously, the whole crew or the whole team is working on the forecast together. But I've always kind of like that. We're going to get into now. What caused your week to be so busy? I mean, I just saw you on Channel 4 this afternoon. You were in the New York Times. I don't know who else you've talked to, but you've been through no pun intended, James, a lot of whirlwind of activity over the past 5 or 6 days here. And my intro to this question, I did write, when you walked into the Weather Center last Wednesday, you really didn't know what was going to happen. But I saw your Channel 4 story this afternoon, And you, being a good forecaster, you kind of did have an idea what might happen. Take us back to last Tuesday and then into Wednesday, and kind of tell the story of why you've been so busy talking in the media for the past 5 days.
So on Wednesday, February 15th, I was working my very first lead forecaster training shift. And so going into the day, because of our convective outlooks, which go out through 8 days, we already had a severe risk across parts of the US, mainly from the Arklatex, Southeast Oklahoma into the Southeastern US, Mid-South region. So we already had forecast a severe threat. We knew that there were going to be storms. So the night before, there was a lot of excitement, anticipation, a little bit of nerves. Didn't really sleep that well. And so, 8 a.m. rolls in, I'm at the office, and, early on, I'm thinking, okay, today is going to be the day that I finally get to issue my first severe thunderstorm watch. And it just so happened that I was the first female forecaster at the Storm Prediction Center to be able to issue a watch. And so that was extremely exciting. I think I said on a Facebook post, 13-year-old me was crying and screaming inside whenever I finally got to do that. So just a really exciting day. But yes, I knew ahead of time that it was possible.
This reminds me of Neil Armstrong stepping on the moon. One step for you, one big step for females. How long have you known that no female had ever issued a watch?
Well, we started talking about it in operation several weeks ago because we knew that my training shifts were coming up. And so we'd been talking about it. And there's only been one other female that it has been in the the forecaster ranks that I'm currently in. But it was back when SPC was back in Kansas City. So it was before the current iteration of SPC. And in that position, they did not issue watches. And so she had never had the opportunity to do that. And so given that I am in the mesoscale outlook forecaster rotation, back in 2011, we started doing cross-utilization training at SPC. So that was where the lower graded forecaster group was able to train on the next higher level desk. And so that once I've been in the rotation for 3 years as a meso outlooker, then I was able to start training as a lead fill-in. And so that's what the series of events that kind of led to last Wednesday.
Because typically, if you're not doing a cross-utilization training, it's one of 5 names that's going to be on the bottom of that watch every time. One of the 5 lead forecasters. So
yeah, we only have 5 leads, and in the 60+ year history of SPC cells, there's only been 36 lead forecasters in total. So it's a rare opportunity. And whenever you become a lead forecaster, and really most people who come to SPC, it tends to be the place you retire from. That we don't have a lot of turnover typically. And so those opportunities just don't come around very often.
Liz, it's awesome to meet you. And I just wanted to tell you that I was at lunch today with a couple of friends who I play tennis with, and they are not in the weather world at all. And sat down, and one of them looked at me and said, "Big news in the weather world." And I'm like, I'm thinking of the winter storm or tornadoes or something. And she's like, first female to issue a watch. That was so neat for me to have that. So I love the fact that this has got such a big reach, and that so many people are getting to talk about it, and it is such a big deal. Just talk about your experience. I mean, the fact that this has been going out beyond just weather folk, is going out to many people and having a big impact. Just talk about your experience a little bit with it.
Well, it was definitely unexpected. So whenever I made like my initial posts to Twitter and Facebook, I did it on the way to my car after my shift, and it had been like 10 minutes since I issued the watch because it happened right at the end of the shift. And I was just really excited because it's like, this has been a goal for me, like, forever. And I was like, well, nobody's going to care other than like my mom and dad, and maybe a few friends, who I've been friends with for a long time, maybe a few weather nerds. I honestly had no idea. And I was off work the next day, and I woke up, and I had gotten calls from my boss and like our public affairs person, and like a ton of emails. And I was like, what is happening? Totally unexpected, but amazing. I'm thrilled to be able to support women in meteorology and STEM in this way. I have a 5-year-old daughter, and I think representation matters. Whenever people see others who look like them doing the things that they dream about, it becomes reachable. So it's been overwhelming but amazing.
Sorry, I've got too many things. Go, Kim.
Oh, I was just going to say, I wanted to chime in with a really quick, my favorite Liz story, just to hammer home how long Liz has been working for this goal. She has been at SPC doing this for a really long time. You underscored that you had started doing some of this stuff back in 2011. So 2011 was a big year in Oklahoma for tornado outbreaks. It was also a big year in her life. She got married that year. One of my favorite Liz stories is she was balancing her work commitments with her upcoming wedding. I think it was that weekend. You brought your wedding dress, but she had this full, beautiful wedding dress. Everyone was sheltering in the weather center that day. Like, it was just sort of the thing, May 24th, 2011, that we all did. It was 2 days after the Joplin tornado and a month after the Southeast outbreak, and everyone was just really on edge, and it was going to be a bad day. It was a bad day for parts of central Oklahoma and western Oklahoma. And oh my gosh, we were just all sheltering and putting things in our offices. And I see Liz run by, and she's got this huge wedding dress. And I was just like, well, and there goes the Storm Prediction Center, but it's something that would only happen to a woman who is working at the Storm Prediction Center and balancing all of that. And, I would love to hear your, when you look back on all of the years that you've been there through that process of getting married and of having your children and staying there in that role, knowing how slow turnover is. And, maybe not even knowing when you'd get to this point. But I'd love your reflection on all of those years and all those milestones you've had in your life on your way to getting to this point.
Yeah, so yes, I've been at SPC now going on 14 years. So it's been a long time coming. But I mean, yeah, most of my adult life has been spent at this SPC and through all of those milestones. And, it took me about nine and a half years to be promoted from the mesoscale assistant to the meso outlook forecaster. And there were opportunities before I was promoted. And, I have to say, I had 2 kids, 2 very rough pregnancies. Both of my kids were born prematurely, and it was very scary and traumatic. And, my focus wasn't always necessarily on moving to the next step, because I was a mom with young kids and shift work, and it's very overwhelming and it's extremely hard to do. And so I don't want to sugarcoat that part. There are, I think, challenges for women who work in jobs with shift work and still, they want to live the whole dream. They want a family, they want their kids, they want a successful career. And you can't always have all at once at the same time. You have to prioritize. And so, I think that it maybe took me a little bit longer than it might have, but I was determined. I knew what I wanted, and so I kept at it. And, my mom, she always tells me whenever, because I'm very hard on myself, and she always tells me, Liz, your time will come. And, I think she's exactly right. And it did finally. It may have taken a little bit longer, but it happened. And so, persistence and keeping your eye on your goal is what's important.
Liz, as a girl dad, I love this so much. And we just stopped down when I saw your tweet that afternoon here in the station, and like, oh, well, we got to find out how many watches there have been, because this is amazing. And I'll email Daryl to find out, because he'll know. There are institutional and organizational challenges that I think affect women far more than men vocationally, and you're probably not able to discuss those with full freedom, but the rest of the panel probably is. What can be done to help equalize that? It's still a very misrepresented, the ratio is still off in the entire weather enterprise.
Well, I do think that the Weather Service specifically is, they're starting to recognize some of these imbalances and maybe inequality. And I think that they are working to address those. We have teams like the shift worker team who's trying to work on ways to, make our shift schedules more tolerable and more favorable for, getting that work-life balance, which in my experience, there's no such things. It's just sometimes you focus on one and sometimes you focus on the other. And, that you don't have to be, you can't do all at the same time. It's just impossible. But I do think that, the culture is changing, and that, the organization is trying to address that and make things easier, make things better. Because, people, I think, are really realizing, like, shift work's not good for anybody, but, I do think it has in a disproportionate burden on women, especially women who decide to have families. And so, I'm encouraged by a lot of the work that's going on currently within the organization to try and address some of these issues.
Dr. Dale Jacobs, talk about the parallels at the Hurricane Center. How are they doing in terms of positions coming along with female forecasters?
I mean, I think it's the same across a lot of NOAA. It's headed in the right direction, but they've got a long way to go. And I think, for young women looking at what they want to pick as their major and looking at colleges and programs, to have role models like Liz to look at as someone who's sort of breaking through some of these barriers is really, I think, what's going to probably push them to go forward with it. So I'm really excited to see things like this happen. But it's also a little bit frustrating to look back and say, why did it take so long?
Mm-hmm. I thought the very same thing when I was posting my blog post. Dr. Harper, you get the last word for Liz tonight.
Well, Liz, I was so excited to read your story in the New York Times, because I went, woohoo, because when I came into the business in 1974, really there was so much pushback. And you talk about having kids. I did 2 kids while I was on active duty in the Navy. With one of them, I had a big 5 days off afterwards, because I needed to be back. So we really need to be working on this so that everybody is included, because we need everybody's weather brain out there, not just guys. So I'm really pleased. I'm really pleased for you. And I hope to get to Norman sometime. I'm doing some work with some folks out there, and I'd love to talk to you when I come out.
Yeah, that would be wonderful. Thank you so much.
And Liz, let me just say, and I'm sorry, Rick, this is a true story. I had a young woman that came by here last Friday. She was about to graduate high school this year. She's been accepted at OU, and you'll never believe what she wants to be. lead forecaster at SPC. And that was about the time this all came out. So I don't think you'll ever understand how much encouragement you have given young women that want to follow in your footsteps. So I just wanted to thank you. And I would assume that all the other leads forecasters are very supportive. It seems that way.
Yeah, thank you. That's amazing to hear. But yeah, everybody at SPC is very supportive. The day that I issued the watch, everyone was kind of gathered around my workstation, watching. And I turned around just before I sent it and was like, "Evan, take a picture. It's my first watch." He was like, I've already been taking a bunch." And I was like, "Oh, amazing." But yeah, we all just kind of celebrated together. And so yeah, it's been great.
And what's so odd was a goober from our TV station was actually there when this happened, and they have video of this.
Yeah.
So that they've got exclusive video, but was kind of cool. But again, the whole story is just great, and I hate to stop here because this is so good. I mean, this could be a 5-hour show, but we got to take a quick time out and hit Tony Rice and his report, and then we've got Jen's This Week in Tornado History. We're going to bring in Bruce Jones after that, Bill. I'll let you bring in Bruce, and we'll do a quick pick of the week here for all of us. But let's take a quick pause, and we'll be right back as WeatherBrains rolls along.
Looking beyond the atmosphere, here's Tony Rice with your astronomy outlook.
Venus and Jupiter continue to draw closer in the evening sky. Look after sunset, and you'll first see bright Venus appear, followed shortly by Jupiter up and a bit to the left. On Wednesday, February 22nd, the moon's going to pass through about a degree of angular separation from Jupiter, or about the width of your pinky. The moon also continues its march through the sky when on Monday evening, the 27th, it will pass Mars, also within about a degree. Now, Jupiter and Venus will continue to draw closer through mid-next week, when on the evening of Thursday, March 2nd, they'll be separated by about half a degree. So take a moment over the next few evenings and watch that separation disappear. Also notice how much brighter Venus is than Jupiter. Astronomers use a logarithmic scale to measure apparent brightness. Smaller numbers are brighter, and it's all based around first magnitude stars or planets or whatever being about 100 times brighter than sixth magnitude stars. For comparison, your eyes under the darkest skies are capable of seeing about a 7th magnitude star. Space telescopes like the Hubble and the James Webb, well, they can make out objects dimmer than 30th magnitude. Over the next few weeks, Jupiter will be shining at a negative 2.1 and Venus around a negative 4, or about 5 times brighter. That's your astronomy outlook. Follow me at RTP Hokie for more spacey stuff like this.
This week in tornado history, 7 tornadoes were confirmed on February 23rd, 1975 across parts of the South. One of the most significant of the day was given an F4 rating. It moved through parts of Tuscaloosa County, Alabama. The path length was estimated at almost 14.5 miles. Several homes were leveled south of Tuscaloosa, and in the southeast part of town, significant damage occurred at the intersection of I-59 and McFarland Boulevard. A new Scottish Inn motel was destroyed, and 23-year-old housekeeper Thelma Hill was killed when most of the second floor of the motel was sheared away by the tornado, causing a wall to fall on her. There was heavy damage to a nearby restaurant and several other commercial buildings. In the Holt area, about 30 homes were destroyed. Falling trees damaged several other houses. Close to 50 people were injured during this tornado event. You can read our summary about this tornado and hundreds more at tornadotalk.com.
And it is that time of the week. First, we have to recognize Jen for that fabulous report there. Jen, that was an important event to me because I was 13 years old and really getting into the weather. And I'm glad you added the name of the lady who died there, because that's what you do in all of your summaries that you write for Tornado Talk. You personalize it. And I appreciate that. That's going to be my weather history tweet on the day of that. Of course, we're getting into that time of the year And it's that time of the year for our Midland Radio sponsor host, Bruce Jones. Bruce, you're in South Carolina tonight talking to emergency managers as you're wont to do this time of year. What are you hearing from some of your colleagues there?
Well, Hurricane Hugo, I'm in Charleston, and Hurricane Hugo slammed into this area in 1989. That's been a long time. And, America is a very mobile society. We move around. I think the average American lives like 6 different places in their lifetime, 6 different locales. And, you always are concerned that people who've moved here within the last, 10, 15, 20 years have no real history, no feeling of the history of what can happen here. But I just saw South Carolina Emergency Management on their website says there's like a 79.9% chance in any given year that South Carolina is going to be brushed by some kind of a tropical system, whether it's a storm, depression, hurricane. So, this is one of the real challenges in emergency management, how to get people to think seriously about the risk factors involved in living in a certain area, whether it's tornadoes or flash floods, wildfires, hurricanes. And it's a continual challenge to them. But they get together and they constantly, work on these things, and they're a very dedicated group of people. They don't get paid a lot of money, and as always, they're champagne taste on a beer budget. I mean, they're trying to do things and pay for things and buy things, and it's always tough for them. So it's a tough job, but they really love it, and it's a passion for them. So it's fun to be around emergency managers. It's an interesting crew of people, and they have an encyclopedic knowledge of so many interesting and sometimes weird and frightening things.
So Bruce, you're there as the national spokesperson for Weather Radio, basically. We're all the disciples of Weather Radio here on this show. And we encourage all of our listeners to be the same way, and we know most of them are. You've got a special deal for any of them who want to get weather radios for themselves, their friends, their family, that's tied to this broadcast.
Yeah, if you're a listener to the podcast or you view it online, if you love WeatherBrains, we've got a special offer for you. Go to midlandusa.com. And when you use the promo code SPAN25, that's SPANN25, SPANN25, SPAN25 is the promo code that gets you 25% off all the weather products and accessories. So if you already have a weather radio yourself, maybe you got one that you use at home, maybe this is a time to get one to take with you when you travel out to Colorado, when you travel out west, if you go somewhere in your RV. I've always advocated that everybody that goes out on a boat on a large area of water, whether it's the Gulf of Mexico or any of the Great Lakes, should have one of these emergency hand crank radios with them, because the flashlight on here is extremely bright. It's an LED flashlight, and it will flash Morse code SOS. So if you're out on Lake Erie and your motor goes kaput, you've got a SOS flasher that you can turn on. Weather.com or midlandusa.com is the website, and the promo code is SPAN25, SPANN25, gets you 25% off all the weather products and accessories at midlandusa.com.
All right, Bruce, thank you so much. And again, it's like a smoke alarm in your house for a tornado. Everybody needs one, and you can help us by being an evangelist in letting your friends and relatives and people in your circle of influence know that they need one. It's the baseline. It's very, very important. I can't stress the importance of that. So, Bruce, we'll come back to you in a minute. And by the way, we'll do picks of the week here. And Jen, I've got to say that like Bill Murray said, the 23rd of February, 1975, my closest encounter with a tornado in my life was that one. I was within 1/2 mile and working that Sunday afternoon. And I could talk about that one for a long time, but that was an excellent piece you did. So thank you. In fact, Jen, let's get your pick of the week. Let's start with you. And by the way, for everybody on the show, everybody, be thinking of a pick of the week, as we'll come to everybody before we wrap up here, something that's really good, that's weather related, website, hardware, software, anything weather related, social media posts. But Jen, let's go to you. What's your pick of the week this week?
Thanks, James. Yeah, it's a tweet actually from the Sirens Project, which if you haven't checked them out, they're a really neat group and they help folks in disasters. But they posted a tweet today. They were en route to the Disaster Response Roundtable in Memphis, and they stopped in Hackleburg and took a photo of the monument there. 210-mile-per-hour winds were estimated where this memorial stands. Reminders also, they are still a lot of concrete slabs that are still there. I think it's just so important to remember what happened. And that's why we do what we do at Tornado Talk. We want to look back and remember what happened and try to remind ourselves of these events so we can learn for the future. And so I just thought it was just a poignant post from that group.
Awesome. And again, all the links will be up on the website, weatherbrains.com. James A., you've got a newscast in a couple of minutes, so let's go to you next.
Yeah, another pioneer in weather, Dr. Danae Carlos is now the boss at the National Severe Storms Lab, and he is a Tulsa kid, and he went to school with our big investigative reporter here, and she turned a 4.5-minute long story on it when he came back to his middle school. So that is my picture of the week. He is the first African-American head of a NOAA agency, if I have that right. So totally proud of him, and he knocked the socks off everyone at our chapter meeting of the AMS. So expectations of just greatness at NSSL.
Outstanding. That's going to be great. All right, Dr. Jacobs, what you got for us this week?
So my pick of the week is some new evidence linking black holes to dark energy. So this was explained in Einstein's theory of gravity, but no one until recently had actually been able to I guess, prove it with observations. And it was always kind of an unknown in the theory. And it was kind of a placeholder where people assumed it was there, and now they've actually seen it. So it's a University of Michigan press release, and there's 2 papers cited in it, and it describes their observational evidence. So pretty exciting.
Very cool stuff. All right, Kim, what you got for us this week?
So this pick is motivated a little bit by something Rick and I are going to talk about next week. He and I were chatting about this. We did an integrated warning team meeting in central Oklahoma that was great. As tornado season is upon us, I'm sharing an essay that Harold Brooks and I co-authored at the start of COVID to try to inform people about safe sheltering practices. It turns out most meteorologists don't even know how well ordinary structures hold up in tornadoes. And it turns out to be really, really important information for people so they can take successful protective action. We'll talk about it more next week, but that is my pick.
Ooh, can't wait for that show. All right, Rick Smith, what you got for us?
Yeah, Kim was a big hit at our IWT workshop. We'll get into that more next week. My pick of the week is something both Kim and I, something else we're both involved in. The AMS Weather Band has this Jamposium 2023 coming this weekend. It's Friday afternoon and Saturday, looks like, afternoon as well. A ton of great speakers. It's free for anybody to attend. If you want to get the recordings later on, you have to be a AMS Weather Band member. But just some phenomenal speakers for a free webinar, seminar series here about tornadoes, hurricanes, all kinds of cool stuff. So that's the AMS Weather Band Jamposium coming up February 24th, 25th.
Outstanding. Bruce Jones, give us something good.
Hey, I was going to talk about the upcoming snowstorm. And so I was going to the Nebraska Historical Society website to look up some of the blizzard of 1888 stuff, because they've got 2 historical markers in Nebraska about that blizzard. But I found something even more interesting. Nebraska, up near the town of Ellsworth, which is in the Nebraska Panhandle, actually has a historical marker where a Japanese bomb balloon landed in World War II.
What?
According
I
to
had no idea. I knew they hit the Northwest coast, but not
there were
Nebraska.
5 of them that landed in Nebraska. And
wow,
you can't get more centrally located in the United States than Nebraska. There was an enormous ammunition plant in Nebraska that made the majority of all the shells that were shot out of the battleships in the U.S. Navy during World War II. And the Japanese sent some balloons across, and 5 of them landed in the state of Nebraska. I'll send you a link to the hysterical marker.
And you see, you don't get this on the other shows, only on this show. I mean, that's awesome. How cool is that? All right. So let's see. Will, give us a good pick. Will's been working on this. I sense something good is coming.
The latest thing is the new director of the Bermuda Meteorology Service, Michelle Pitcher, actually came from the NOAA Climate Center lab from Silver Springs and recently got promoted, and Bermuda is lucky to have her.
Indeed. All right. Awesome. Okay, Liz, give us a good pick.
All right. I'm going to stick with my theme of the week, I guess, in building up women and girls in STEM, and give a shout out to the Girls Who Chase organization. On March 4th, we are holding what we call spring training, and it's co-hosted with MetEd and Comet. And in our workshop, we'll be talking about weather safety, pointers for storm spotting, what types of reports, the Weather Service is interested in, the structure of the Weather Service, things like that. And really, this organization is great. It's a grassroots effort focused on education and supporting women and girls and amplifying their voices in the weather world. And you can visit their website at girlswhochase.com.
Awesome. And again, thanks for your great leadership and influence on young women that want to do this. So you're a great leader, Liz. Thank you so much. And before we go to, let's go to Dr. Harper next. Dr. Harper, go. What's your pick of the week? I know you got something good for us.
I have to unmute first. Well, so I just, since I'm in Denmark, I just want to tell folks that if you're traveling to Denmark, make sure you go to DMI, the Dansk Meteorological Institute, before you come over, so that you can get the latest weather forecast for what's going on here. The big center is here in Copenhagen. And even if you don't speak Danish, you can figure out what's going on with the weather from their site.
All right, good deal. And my pick of the week before we go to Bill, I got the coolest cake today. So I spoke to some 4th and 5th graders, and on the cake there was a SKUT plot.
Who in the world did that? That's incredible.
It was the most amazing cake I've ever received. I mean, in terms of content, it was just remarkable. So anyway, there's a tweet with video and pictures and stuff, but it was just too cool. All right, Bill, take it away. Go.
Yeah, James, a couple of programming notes to what Liz said about Women Who Chase. Jen Walton will join us on March 20th. Looking forward to that. She's a good friend of the podcast, previous guest. And next week, Dr. Scott Radowski will be talking about the GLM. James, that was your command performance. My pick of the week, this is a copy of it. My pick is going to be the electronic copy. Tomorrow is the anniversary of the Mississippi Delta tornadoes in 1971, which is a very formative outbreak for me. A very terrible day, a Sunday in Mississippi, and very deadly outbreak. But this is an outstanding report to the administrator. We've had a lot of great post-disaster surveys, but this is a superb one, talking about what the Weather Service in Jackson did that day with very limited resources. And a lot of people in all of those communities that were devastated actually heard the watches, heard the warnings. They knew the tornadoes were coming. The death toll was still very high, but it was not as high as it could have been without their valiant efforts. And That's all I've got, James.
Okay, great. So real quick, Will, tell us how people can follow you on social media or plug whatever you want to plug. Go. This is your plug moment here.
Anyone who wants to get in the meteorological community and start using numerical weather, please follow me on GitHub, Hathaway Will. I have developed weather models for anyone to access the WRF, and it's a great introduction to get into it.
Awesome. Anybody that's got a GitHub site, the guy's good. I mean, this guy's good. That's awesome. When you hang out on GitHub, that's the good stuff. That's awesome. All right. Let's see, Liz, how can people follow you? Anything you want to plug? Twitter, Facebag, anything?
Yeah, I'm mainly active on Twitter, and you can find me at WeatherWX Liz.
Awesome. And Dr. Harper, anything you need to plug before we wrap it up this week?
Well, I don't tweet. But if anybody's interested in weather control during the Cold War, my book "Make It Rain" is pretty hilarious for an academic book, and is written for the general population, and it's non-technical and has all kinds of wild stories in it.
I like wild stories. Amazon, what's the best way to get a copy?
Yeah, you can get it. Yeah, you can get it on Amazon. You can get it on Kindle. Yeah, so it's it's out there, published by University of Chicago Press.
Awesome. Well, listen, thanks to all of you. Again, we could stretch this thing out for hours, but I hate to wrap it up, but we got to wrap it up because some of us have to get back to working here. But if you're new here, WeatherBrains is recorded every Monday night at 8 o'clock Eastern, 7 o'clock Central. We have a video version. You can watch it live via video, youtube.com/WeatherBrains. But we know that most of you listen. And if you want to get in touch with us, our email address, it is email@weatherbrains.com. We had to skip the email segment this week because of time. We'll come back with the longer segment next week, but we'd love to hear from you. Thanks for listening. Thanks for watching. On behalf of the entire WeatherBrains crew, I'm James Spann. Have a great week and God bless. Thanks, everybody. That was an awesome show.
Thank you, Rick, for getting
great.
Liz. And Dr. Harper, thank you so much for getting up early for us.
And thank you, Dr.
Thanks.
Harper.
It was really fun.
And thanks for being here, Will.
Oh, my pleasure. Hopefully I can still get more users. Shame I didn't get to show the map, but I'll show you guys if you give me 2 seconds.
Go. We're still on YouTube. Go.
Oh, we're still on YouTube? Okay, let me share the screen.
Hey, Bruce, while he's doing that, are you going to be at the Oklahoma EM conference next week?
Yes, I am. At the 6th largest casino in the world. You bet I'll be there.
Awesome. I'll see you there.
Hey, Bruce, host, I need permission.
You'll know where to find Bruce.
Durant, Oklahoma. Can you imagine? The 6th largest casino in the world is in Durant, Oklahoma, and it's beautiful.
And the largest casino in the world is in Thackerville, Oklahoma.
What was that, Rick?
The largest casino in the world is in Thackerville, Oklahoma.
Really?
Wow.
Was
Hey, try it again.
Northeast.
Try it again, Will. There you go.
Let's see. Here we go. Can you see the map?
Yes, sir.
Yep.
So this is a map of all the countries in the world that have utilized my WRF multi-operational system install code. It's really popular in developing countries. I have reached a major milestone, which was 103 countries. And for anyone who knows their geography, there is 195. So that is over half of the world have used the WRF model code that I developed. There are some really interesting ones. We got Iraq, but a lot of the smaller nations like the Solomon Islands, Papua New Guinea, Cuba, Costa Rica, a lot of the Western African countries are very interesting. The very tiny little nation of Cape Verde. And for anyone who's listening, the WRF model code installs WRF Chem, WRF Hydro, the hydrology module, and Hurricane on Linux, Mac OS, and Windows. That's all I need to plug for me.
Man, that's awesome. That is good stuff. All right, guys. Thank you all. You'll have a great week.